Perfect. Hey, everyone. Thank you for being here, especially on an afternoon in Paris where there is a lot happening. Um, so I am Tanisha Katara. I work with Polygon Labs as a consultant, and also with a bunch of other protocols like Ethereum, DAO-Lens, DAO-Cals. Prior to this, I was leading strategy at Juno Finance, which was a crypto-native banking for the States. It's exciting to be here, but today what I want to essentially talk about is interoperability. And I think I want to perhaps go deeper into how, a case study specifically on how interoperability is being used at Polygon. So let's get started. You see something there which says Polygon 2.0. For those of you who perhaps may not have context, Polygon 2.0 is the next generation where they intend to create the value layer of the internet. So expect a lot of changes. Expect the tokenomics, the governance models to be changing, and I am very optimistic that it's in the right direction. But this isn't about Polygon. This is about interoperability, and I'm happy to take any questions that you may have on that. OK, so let's move. Check this, sorry. OK, so I'm not a big fan of keeping presentations really technical. So you are in a Shakespeare play. We have 4 acts. And we have an opening act, of course, which is about what happened last night. It's story time. And we have more context on how we get there, the part to build, and of course, any Q&A that you may need. One quick tip for anyone here. If there are terminologies or jargons that you don't specifically understand or want more context on, I'm going to be there for a bit right after this talk. So please don't hesitate to ask any questions on that front. OK, so last night, something really interesting happened. I was with my team at the hotel, and we were having a conversation. And Mateusz is the governance facilitator at Polygon Labs, and Bojana is the chief of staff. So we were in the middle of a conversation, and Mateusz was giving feedback that Bojana, who is, by the way, an amazing woman at Polygon, is the super glue that holds people together who otherwise wouldn't be together. And it was so interesting because I said, hey, I'm going to steal that line for interoperability. In the truest sense, interoperability is the super glue that binds together otherwise unstickable systems. But what exactly are we talking about? So, when you build systems and infrastructures, especially data availability, which kind of speaks to multiple systems and multiple layers, how do you create a unified language for all of it to work efficiently? And that is where interoperability becomes extremely important. It's not just about user experience, it's also about security, right? And so this is the Polygon architecture. Just to give you a quick overview, and please use this as a case study, right? Tell us what we can do better. The architecture essentially starts with the settlement layer, which is the Ethereum, and then you build the Plonky ZK proving system. So essentially, we've been using Plonky 2, and now we have a much far mature system, which is Plonky 3, which I'm going to get a little bit deep into in a bit. We have the ZK EVM, the Maiden, which sits right on top of the Plonky system. You can also be a single client. And the way we are unifying assets and information across all of this is the LXLY bridge, which we'll also kind of get deep into. It's a really interesting bridging solution if you're interested to know more. We also have the staking hub, which is honestly where we facilitate decentralization. So prover availability, sequencer availability, data committees. This is where all of it gets organized. And the interesting part is we're introducing restaking elements to kind of also allow capital to be more fluid and more liquid. I'm going to get into that in just a bit as well. And of course, on the staking hub can be centralized, decentralized, public, private networks that communicate with each other. But hey, hold on. We're talking about interoperability, and now we're talking about the architecture. What is the goal? Well, the goal is that we want to use interoperability so that in this cosmos of chains that Polygon has, how can we build something that feels like a single chain with unbounded block space, unlimited scalability, and unified liquidity? And that's been a very, very interesting journey for us to kind of achieve these aspects. So let's get into the architecture. Let's break it down further, and let's actually see how we're doing what we're doing. So to start up with, this is the inter-rollup composability. So just to give you a summary, you have your POS, your Validiums, your ZKVMs, and all of these essentially are going to be constantly communicating with each other. And that not only reduces gas, so we're going to have like periodic windows of aggregate proofing, which allow these massive transactions to bundle them and then settle them. So it's going to be like almost like one of the cheapest yet unified, and the L2 can talk to L1 really fast. Currently, LXLY is being used as a bridge between the ZKVM and the Ethereum layer. So we want to create this constellation where all the ZKVMs, Validiums, rollups, POS can communicate with each other using the LXLY. In fact, it's already live. We've been testing it with the ZKVM. We also kind of want to go deeper into shared liquidity and decentralization. So think of it as all of us have different needs, right? I may not necessarily need a decentralized sequencer versus something which actually cares about decentralization would need that. So how do you create systems that have different data availability requirements, different costings, different budgets, different speed requirements, different security requirements? This is where we kind of see every single chain on the staking hub, the child chains, will have its own properties, its own unique properties. Yet, the underlying technology will be an LXLY bridge, a singular smart contract that connects it all securely. And I will explain the global tree roots of the LXLY bridge, which is honestly very interesting in a bit. So you have multiple rollups with a single liquidity pool. You have centralized or decentralized sequencers. This is where it gets interesting. Today, a validator does one job. They validate transactions. But in this system, in the staking hub, a validator can do multiple jobs. So you enter the staking hub. You can say, hey, I want to validate for the POS. These are my rewards. I want to enter the sequencing. These are my rewards. Or I want to be a part of the data availability committee. And these are my rewards. Each of them will have their own slashing and eligibility requirements that the validator will need to or the service provider will need to meet. And each of them are also going to have their own risks. So think of slashing, think of reputation. And now the validator can use one stake to participate in multiple pools to kind of get more rewards, with also higher risks, of course. So this is the interesting aspect of creating a shared liquidity and a unified liquidity. And like you can see on this side, the staking hub is where all of this coordination really happens, right? This is the proof of aggregation. So this is the bridge coordination layer, where what we're trying to do is, if there's so much happening on the chain, how are we going to ensure there's no latency, right? This is where we reduce the latency by bringing an aggregation layer. It operates on the latest state of the transaction, and they're checked at the aggregation layer, proofs are aggregated, and then posted to the settlement layer, which is Ethereum. Now, how did we come up with these components? What does it mean to be building these things? So let me start with the staking hub, because honestly, this is, like I said, this is where the whole coordination or decentralization happens. You have two stakers. You have staker A and staker B. Let's just say that staker A has a DAC role. He works in a data availability committee. And staker B has two roles, which is a DAC role and a prover role, because they've restaked their liquidity to participate in another additional job. Now, stakers can subscribe to one or more roles that a chain offers. And like you can see, your rewards can be in multiple tokens, and your penalties can also vary from a service to service. So for a DAC role, you could be earning in Pol, you could be earning in IMX, or you could be eventually earning in ETH. So based on the service you kind of enroll in, you have different slashing and different reward experiences. OK, this one is the LXLY bridge, something that we've been talking about, which plays such a huge role when it comes to interoperability. LXLY bridge is essentially that unified smart contract bridging solution that connects layer 2 to layer 2, or layer 2 to layer 1, and vice versa, right? This is the Ethereum mainnet. It sits right on top of it, and then you have your app chain 1, your supernets, your zk-POS, your mainnets, all of it communicating via the LXLY bridge. Now, I'm not going to get too technical, but it is really interesting to understand how the underlying LXLY bridge works. I'm going to just touch upon it for a bit. So there are 2 trees, OK? Now, visualize 2 trees. You have your exit trees, and you have your global trees, right? Exit trees are what each child chain is going to have, right? So if I'm a supernet, I'm going to have a tree, and every transaction I do will have a leaf, right? And essentially, that leaf is a compressed version of my data, right? So you have your origin address, you have like a really metadata that kind of compresses this, puts it in a leaf, and you can kind of, once the sequencer sequences these trees, these leaves, it sits on the exit tree. And each of these leaves will also match the leaves on the global tree. So this global tree is essentially going to sit on Ethereum, where you can kind of verify, you can say, hey, this is my leaf. And if it matches with the tree, you can force your transaction on L1 directly at like a really cheap cost. So that is essentially how L1 and L2s can talk directly. Using this phenomenon, an L2 can talk to another L2 without actually going via an L1. So that also makes LXLY bridge really interesting. Plonky 3 is, thanks to our partners, we've been kind of trying to build the efficiency layer, and Plonky for us is that efficiency layer. We've been doing at a high level, this is a whole other talk, but at a high level, this is what Plonky 3 is going to look like. A lot of polynomial commitment schemes, fiat chamber implementations, better compression techniques, faster data availability, and essentially more powerful batching is what we're hoping to kind of see coming very soon in the whole architecture. But here's the thing, right? This isn't, like I said, this isn't about Polygon. When you're building in Web3, you're not building alone. You're building alongside a community. And so these are our partners without which it would be absolutely impossible to build this. And it's kind of been an exciting journey to collaborate with the ecosystem at large. So the end goal here is, let's do something together in the sense that what are some thoughts that you may have to make this a better system? We may have the best technology, we're exploring better compression techniques, but what are the elements that we're perhaps missing? We actually have something that makes it easier for you to give your feedback. Just yesterday, we launched something called as the Community Vision Board. Now, this isn't any high-level blog. This is essentially every single pillar that governs the Polygon 2.0 has been broken down into like specific problem statements, and it is a massive invitation to the community to come collaborate with us. So whether you're a community manager, whether you're a developer, whether you are somebody who loves security, this is like the massive invitation to the next Polygon era, which is the decentralized era. So I would love to have all of you drop your feedbacks there. And yes, thank you so much.
Thank you, Tanisha.